Well, hello there. This is Miss Becky again, and today we're going over, it's IXL, uh, section J1, talking about the domain and the range of logarithmic functions for pre-calculus. So, just for your little amusement here, I have some exponential jokes for you that are pretty funny. Um, and if a logarithm is just the inverse of exponentials. So the b here, this for this exponent, the b is the base, so we could say it's 5 if the base is 5. X for an exponential function is just an exponent, and if you remember, that just means multiply this base by itself that many times. So 5 to the second power is really 5 times 5, which is 25. And there's your answer. But for logarithms, they are the inverse. They have to do with exponents, but just in a different way. So if you have log and then you write the base down here, see we had the base b here. Now we've got the base b here. And this is called the argument. The argument is, I like to call it the answer. So log base of 5, the answer is 25. What you're looking for is the exponent. Again, this is a little quick review. What number, how many times would I have to multiply 5 by itself to get 25? And so the answer would be 2. Okay. Oh, wait 1 second. Wait 1 second. Well, okay, it didn't beep. I didn't know it was recording again. Anyway, here's just a little bit that I printed out for you on your notes about logarithms. So in they relate to geometric progressions or patterns, um, and so because they are like patterns, there can be many examples that are found in nature, in art, spacing of guitar frets, which I don't quite understand. You get into sciences, the hardness of minerals. Uh, it has to do with sounds, uh, the stars, windstorms, all kinds of things. Here's some examples of some patterns that can be found in nature. This is a flower, I suppose, sunflower. I'm not quite sure, but anything that has like this sort of um, spiral pattern like that. Here's a storm, and here it is in a seashell. But those are just some examples of where we see these things in real life. But the thing we're going to be focusing on is that in these logarithmic functions and the graphs that we're going to see, there are certain numbers that they can never they can never have certain values, meaning that they're undefined, especially for negative numbers or for zeros. Because you can't take taking a positive base and raising it to a power. Um, there's no number power that can result in a negative number when using a positive base. But anyway, that's just a little review of that. All right, so on to our examples. If you'll remember, our exponential functions had a domain. When we were looking for the domain, it was always going to be all real numbers. Since the logarithmic functions are inverse, it just makes sense that, well, I said that backwards. The range was all real numbers for the exponential functions. Um, I just said that backwards again. Well, anyway, for these, the range are always going to be all real numbers. So that's the easy part. If you can get it out, you can say it. Anyway, so this one's asking us for the domain, and they're giving us a graph here. So looking at the graph, we can see here's an asymptote. So this graph is approaching -3, and it's never going to touch it. Um, so the domain, which we're looking for, is going to be the x values. As you can see, the x values are never going to go, never going to be -3 or below. So they have the answers in that set builder notation, and we just have to make sure that we choose the right one. So it's not going to be this one because that's greater than or equals to. It's never going to equal this -3. So we would choose this one. The domain, the graph is never going that way. All right. And again, here they are asking us for the domain of this graph. And we can see there's an asymptote here, right, at 0. Um, so the graph is never going to go below 0. And they have this in a different notation. Mm. So we're looking for 0 onto infinity. And remember, it will never include 0, so it has to be the parenthesis like this. And it's going to all go all the way up into, whoops, I always do the positive, which I know is not necessary. Positive infinity. And again, you're never going to get to positive infinity, so we're going to use the parenthesis. So it's not going to be this one here. So this would be our correct answer. All right. Now this one is asking us for the range, and it's given us an equation, which we really don't have to be freaked out about because for the range on these, they're going to always be all real numbers. Just always is going to be. So we need to find which one of these that represents all real numbers. And it's going to be negative infinity all the way up to positive infinity. So always pay attention to what they're asking you for. Again, they want range. We don't have to mess with any of this. It's just going to be all real numbers once again. So we've got to find the correct notation that they have there. Now here they're asking us for the domain. So that's going to be a little bit different, and it's not difficult at all. The way that you find the domain is you're going to focus in on what they call here the argument. This is a log of x plus 4. So it's this x plus 4 that we're going to be concerned about, and we're going to set it to be greater than 0. And then you're going to solve it for x. So we subtract 4 from each side. X is greater than -4. So that would be the domain on this. So it's not that difficult at all. Just have to find the right answer. Right here, x is greater than -4. Yeah, we're getting through these pretty quickly. Function. Alrighty. So this next one, sample number 6, I think, is asking us for the domain again. Again, we want to pay attention to the argument part. X minus 1, set it to greater than 0, and just solve the equation. So we're going to get x by itself, adding 1 to each side. That gives us x is greater than 0. That's what the domain's going to be. Wait 1 minute here. The domain. Wait 1 second there. I think I made a boo-boo. What a ding-dong. Oops. Of course I made it 0. Made a mistake. 1. Oh, well, that's why the answer wasn't there. All right, so it's going to be greater than 1. But it's not equal to, so again, we have to have this parenthesis. Silly me. There we go. All right, for the next one, we're looking for the domain. We're going to pay attention to this part, the argument, set it to greater than 0, solve away, add 2, add 2. We have x is greater than, watch, I can add 0 plus 2 is 2. All right. They have it in this set notation, set builder, and It looks like this one is good. There we go. Not too bad. That's all the examples that I had on that one, looks like. So that should be pretty easy for y'all. And I'll see you next time.